Hi, I'm Jay Richards. We're here at the COSM Technology Summit 2023, sponsored by the Discovery Institute in Bellevue, Washington. And we just finished a really interesting panel on graphene. Graphene's actually been a theme of these COSM conferences over the last few years. And I'm joined by one of the panelists, Kevin Wyss. Kevin's actually a student of Discovery Institute friend James Tour, did his PhD in chemistry at Rice University, now works for a company in Houston called Schlumberger. But today we're going to talk a little bit about graphene and just sort of walk through what it is and what the prospects are. Kevin, thanks for joining me.
Yeah, thank you so much for having me. It was really a great experience to be on the panel and meet so many really intelligent people here.
No, exactly. I mean, there's always something to learn at this conference.
Oh, yeah.
So I got to sit with you last night at dinner and sort of talk about, I know you did your dissertation work, right, on hydrogen and the potential for hydrogen fuel and things like that, right?
Yeah,
but
graphene.
you tied that in actually in the presentation, but let's just kind of bring it all the way down to ground floor. So what is graphene, first of all?
Yeah, that's a question I get a lot, and so usually I start by saying, have you heard of carbon fiber? You know, very light, very strong material, but expensive, right? So it was only used in really advanced sports cars or tennis rackets, things like that, and so. That's, I say, what if we had something that was even stronger and even better? Right. And that's kind of what graphene is. So graphene is actually the strongest material known to man. It's just made of carbon, so there's no metal. It's very light because of that. Yep. And then also, it's not just the strongest material known to man. It's actually one of the most conductive materials as well. So you have applications that are possible in material. Can we reinforce plastics, cement, things like that? But also electronics and screens, touch screens, transistors, computing devices. Instead of getting away from silicon, can we use graphene? And so graphene has been viewed since its discovery about 20 years ago, kind of as this magic material, it's a black powder, this black fairy dust, basically, where you kind of put it in whatever application you want and everything gets better. Your electronics get faster, your materials get stronger, things like that. But a lot of the hype has been at the academic level because it's a pretty hard material to make. You would think it's just made of carbon, right? Yeah,
and so it's a form of carbon. That's a key thing, right? Yeah, so we've got several different forms of carbon. Graphene is one of them.
Right, yeah. And graphene is actually one layer of graphite. And so graphite, our normal pencil lead, is... just a bunch of stacked layers of graphene. But when you stack those layers of graphene, they lose a lot of the properties that make them really incredible. A lot of the conductivity and strength, you only realize when you get that one layer by itself. You need that increase in surface area and things like that.
And so graphite, you can find this in nature.
You can mine it out of the earth.
You can mine that, right? Yep. So what about graphene, though? This is something that you got to extract.
Right, yeah. So from the graphite, some people make graphite. They'll take the graphite and pull each graphene sheet off. Exfoliating it, it's called. And so that's one way to make graphene, going from the graphite down to the graphene.
That's top down.
Exactly, It's typically called the top-down method, going from the graphite down to the graphene sheets. Another method that people make graphene sheets by is starting with carbon atoms, either gas or... like methane or propane, as well as solid sources like plastics. My work has revolved around converting plastic, that has carbon atoms in the plastic. Can we rearrange those carbon atoms to make our graphene sheets? So that's typically called the bottom up. We're starting from our carbon atoms and building them into our graphene sheet. So there are two kind of different ways to make graphene, either from that top down from graphite or the bottom up from any carbon source. And so in my PhD, we were converting waste plastics into really high-value graphene. And so we're taking a material that's worthless, it's waste, right? It's even pretty hard to recycle plastics in a cost-effective manner.
Like a broken Lego piece or something?
Yeah,
I mean, what are we talking
even
about?
Mixed plastics, right? So one of the issues with plastics recycling is that you have to separate it into the different types. You have to wash it, and then the product you get out is usually lower quality and more expensive than just brand new plastic, right? But what if we can take that plastic and convert it, rearrange those carbon atoms into graphene? And then, so that's our process is called flash Joule heating, and there's a startup company, Universal Matter, that is commercializing that and scaling that.
And on the panel, we heard from a man that's in Israel that is connected to Universal Matter.
And so they're doing great. They've been around for almost 3 years, and they're almost to tons per day. And so one of the big, to back up a little bit, if graphene is this magic black fairy dust, then why why hasn't anyone heard
Where
of
is
it?
it?
Where is
Yeah.
it? And the problem is it's hard to make, like we talked about,
Yes.
and then also it's expensive to make. And so that's really limited the implementation at an industrial scale.
Okay.
Ford Motor Company was one of the really first. They were at the cutting edge. They were one of the first industrial appliers of graphene. They started putting it into some of the polymers in cars. So there could be graphene in your driveway right now,
If you're
but
driving
most
a Ford.
people haven't heard of graphene. They would love to put it in more of their car parts, but it's too expensive and hard to make right now. And so there's a really big opportunity for graphene to realize the hype, basically.
Okay.
And one thing George likes to say, and I think it's just the perfect analogy, is the aluminum moment. And so if we think back to the 1800s, aluminum metal, just what we make foil and cans out of now, was actually more valuable than silver because we didn't know how to make aluminum metal, actually. Until about 1869, people figured out, there's a process called electrolysis, and we can make aluminum metal very easily.
Yeah.
And so over the next decade, the price of aluminum fell 96%.
Okay.
So suddenly it was cheap enough that people could start using it in everything.
And that took a decade from
From discovering electrolysis to the price falling.
Wow.
And so, people knew already that aluminum metal had these great properties. It was light, lighter than steel, stronger, everything. But it was just too expensive. And so until we discovered a new way to make it, and then once we figured out how to make it, then all the applications follow. And look, it's everywhere.
So
now, right?
so that's the idea. Is that that's where we are now.
Right.
So
yeah.
maybe
everyone knows how great it is. We just don't know how to make it at scale and at a price point that can, allow us to use aluminum cans, right?
Yes, right,
where we just
exactly.
throw out aluminum foil or whatever. And actually, the Wright brothers used aluminum in the motor of their first flight. And had they have to use steel or other alloys, it might not have. It might have been too heavy to fly, right? So that's a great example that once we have better ways to make great materials, then we can unlock all the applications that graphene, in this case, has to offer.
Okay, but at the moment it's in this powder form. Is this because it's just too expensive to make it in larger units, so that it's just in powder? But is the hope that there'll be a way of manufacturing these sort of larger chunks? I mean, for lack of a better word.
Yeah. So that is something that people are interested in. Can we make sheets the size of a piece of paper, for example? So some people are trying to make those, and that's what would probably be used in flexible electronics and touch screens and things like that. You really need a large single sheet. But for a lot of the, I think, early applications like Ford, it is a powder because that's easier to make, cheaper to make.
And so it's going to be as an additive for a bunch of other stuff.
Yeah. And I think depending on the application, the powder might be the best option, honestly.
Yeah.
It might perform the best. So as you change the size of the graphene sheets and things like that, you get different properties. And so depending on what application you're looking at, whether, we want to build a brand new transistor for a next generation computer chip, for the AI boom, maybe. Then maybe that needs one kind of graphene that's made from the bottom up or from the top down. And so there's a lot of space for innovation in the graphene and how we make graphene. Because there's so many different applications that need different types of graphene. And so it's really an exciting space to be working in.
I bet it is.
Because there's so much opportunity and there's so much innovation. It's really exciting.
Well, and I can tell you because, of course, I follow George Gilder and I come to these conferences. I've been hearing about graphene, but almost no one has heard about it yet.
Right.
So you're right here at the ground level on this stuff. Yeah, it's exciting. Kevin Wyss, thanks for joining me.
Yeah, thank you so much for having me at COSM.
Yeah, absolutely. And thank you for joining us. I'm Jay Richards at COSM 2023.